Alright, welcome to my Fusion 360 cable rail masterclass. This is likely going to be for personal use as a future reference kind of thing, but I'm going to attempt to include enough detail that anyone could pick this up and design some cable rail. So let's get right into it. First of all, some standard parameters. Usually we do 2-inch square tubing on the outsides and 1-inch square tubing in the middle. The 2-inch square tubing gets the cable receivers, which require a hole of 0.435 or 7/16, and the 1-inch tubes just have the cable run through it, which is a 1/4-inch cable, requiring a hole set of 5/16 or 0.3125. For the 90-degree rails, such as this, it is rather easy. You simply draw a hole with the radius touching, or the circumference touching, I mean, and space it off with an array so that each hole is less than 4 inches apart. And you just mirror it on the other side, with the circumference being just past the area that needs coverage. You can then extrude that through all these and cut them out, making sure to account for this different hole size, although you can definitely extrude it through and then adjust to make sure they're lined up. Your result will be something like this, where you can see the larger hole on the 2-inch being blocked by the smaller 1-inch. If we hide that, you can see straight through both of them. Fairly straightforward, really easy. So let's hide all that. What we want to do now is look at these. These ones are where it gets really convoluted and difficult. So the same basic parameters are being used. You have your 2-inch, 1-inch, 2-inch. The hole sizes are the same, but they need to be ovaled in a particular fashion to allow the cable to run through them at that angle. So some first things you can do to set up are hollow out the tubes to the appropriate material thickness, and that will change depending on the job. For this job, I have 1/8, 0.083, 1/8. And doing that ahead of time allows you to know how long these holes need to be. The offset will always be the same for the 2 inches, but that will definitely determine how oval the holes need to be. You can also cut off some of these lower pieces so that you have a working edge here to figure out the length of these and how long your array needs to be. But once that is out of the way, the methodology is very similar to the 90-degree rails. You will draw your oval with the circumference, or the radius, I guess, touching, spaced off so that you have gaps of less than 4 inches and mirrored to the other side. Now, what's difficult is determining the length of this oval. So this will change drastically depending on what kind of material you're using, but I will show you this 2-inch one as an example, and the method can be extrapolated to any other size as long as you adjust the parameters. So in AutoCAD, here we have a 2-inch piece of tube with 1/8-inch walls, 0.125, and this is the this is the 2 dimensions that will be used to figure out your length and offset. Oh, and this cable thickness, that's what I was thinking. This is drawn at a 7/16, which opens this up slightly more than it would be otherwise if it was drawn to the actual 3/8 that's required. But the 7/16 opens it just wide enough that we don't have to worry about it jamming or getting caught on anything. And it's pulled off of this. It's simply a copy paste that's been trimmed. That way we know the slope of it will be the same. This one here, top left to bottom right, is the size required for the hole to be ovaled in order to get that to pass through smoothly. This one is required as an offset because you can see here, this hole is being created off the top of this point. And if I take a linear measurement from that point where the hole is started and run up to the top, it is 12.2126. Now, if we do the same thing, you can see this point correlates to here. But if I pull up from that point, that is not where I'm going to be copy pasting. I'm going to be copy pasting lower here. And because of that, the copy paste shifts it down to here where the hole actually intersects. Anyway, coming back to Fusion, top to bottom here, this line is what is intended with this dimension here. The other dimension, this offset 0.0832, is what you need to press on this side. All of these holes on the left will be shifted up 0.0832 in order to get the alignment adjusted correctly. You array that down, and what you'll do is you'll copy paste it from here to here and then shift it up by that amount back in AutoCAD over here. Alternatively, what you could do is paste it from here to here and shift it over your material thickness, which may be easier than going into AutoCAD and determining that with the linear measurements tool. Again, remembering on the smaller sizes, these measurements will not be valid anymore. It will actually be these measurements. In order to view your alignment, what you need to do is add in an angled construction plane with the same angle as this top curve here. So if we inspect this, or not curve, but angle. If we inspect this angle here, it is 56.339. So adding in a plane and an angle at 56.539 or whatever it was, you can see that it is now offset 90 degrees. And if we right click this plane and choose look at, which I still do not have for some reason, here we go. It allows us to view these holes right through the center. And you can see that our alignment is wonderful top to bottom. This methodology results in a strange quirk of the holes on the center post here being shifted slightly towards the bottom at the top and slowly working their way up until they are mirrored at the bottom. Now, I don't think that's going to be a problem on assembly, so I'm not going to bother to fix it, but it could be fixed in future iterations of this methodology. Look at me using big words. Lastly, the typical radiuses we use for these, I'd like to include that. On the 1-inch posts with 0.083 material thickness, we use a 0.09 radius on the exterior and a 0.007 radius on the interior. For the larger ones, the 2-inch with 1/8-inch wall, we use a radius of 0.125 on the outside and 0.03 on the inside. That should do it. Okay, thanks. Bye-bye.